Hey guys, good evening and welcome back. Welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly let me know in the chats with some fire emojis, everyone, if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats with some fire emojis. Everyone, people, everyone. So yes, finally we are starting our NEET 2025 journey, right? Which is also basically for 2026. Yeah, right, from today. And today it's going to be the first session. As I told you, when I launched this particular Achievers batch, which is first of all, one free batch on this particular channel, wherein I'll be taking care of your chemistry, right? So people, here in this particular Achievers batch, which we are starting today on YouTube, we are going to complete each and every chapter of your physics, chemistry, and biology, right? And every chapter shall be done and dusted in just 3 sessions. You know it already, right? And the session duration, right? Session duration is going to be minimum 3 hours. So this particular chapter, which we are going to start today, that is your first chapter of your class 11th chemistry, the mole concept. I am going to complete this particular chapter in exactly 3 sessions, right? Again, I'm repeating, every session is going to be minimum for 3 hours. Every session is going to be minimum for 3 hours. Yeah. So today it's going to be part 1. On alternate days, I'll be taking the sessions. So day after tomorrow, it's going to be part 2, right? And then again, one alternate day, it's going to be part 3. And this chapter will be completely done and dusted. And every single thing I'll be covering here. You need not to worry about anything. I'm going to touch each and every topic of this particular chapter. Not only of this particular chapter, of all the chapters of your chemistry. And same goes with your physics. Same goes with your biology as well. Yeah? Right, people? So all ready with your pen and paper? Are you all ready with your pen and paper? Because whatever things I'll be writing on the screen, I would want each and every one of you to take a note of every single thing, right? I would want you guys to take a note of every single thing. And anyways, at the end of the session, I'll be sharing the PDF of this particular session on the Telegram channel as well. I hope you all are already the part of that Telegram channel. Yeah? If not, you can search Wassim Bhat Chemistry-Official, right? That is my Telegram channel on which I shall be sharing the PDF of this particular session. Not only of this particular session, all the sessions which I'm planning to take on this particular channel when it comes to the Achievers batch, which is particularly designed for all the NEET 2025 as well as 2026 students. Why 2026 students also? Because every chapter I shall be starting from the basics only, from the scratch only. Yeah? Guys, one thing I'll tell you, the kind of the quality content which you're going to get in all the subjects, that will be unmatchable. Trust me on that. You'll get to know that. Yeah? You'll get to know that. So should we start the session? Again, you are repeating the same thing. What is the duration of the session? I told you the duration of each and every session is going to be minimum 3 hours. Yeah? Right, people? So all ready? All ready? I would want some fire emojis in the chats. I want the chats to run continuously. Then only I'm going to start the session. I want the chats to run continuously. Then only I'm going to start the session. Quickly. I would want some fire emojis in the chats. Let me see the Josh of the first session. Yeah? Then only we shall be doing it. Yes, I shall be sharing the DPPs as well on the Telegram. You need not to worry. You need not to worry. But it is just, I would want each and every one of you to be consistent, right? Because I know in the first few sessions, your Josh will be very high, right? Which eventually falls down. But that's something which I do not want from you guys. I would definitely want you guys to stick with me till the end, not just with me, with all the educators who are going to, teach you different chapters of your physics, chemistry, as well as biology here. All right. Can we start then? All right, people. Perfect. Yes. Each and every chapter shall be started from the basics, from the scratch. You need not to worry. Everything from the basics. All the problem patterns I'll be covering here. Right? So this chapter I'll be completing in maximum 9 to 10 hours. Completely. Right? From zero till you become the heroes. Perfect, guys. Perfect. So I think I'll turn the night mode on. Yeah. Because these lights will be distracting us otherwise. I think this mode is perfectly fine. Just a second. Just tell me, is the board perfectly visible to you? Just tell me, is the screen perfectly visible to you? Yeah? Just tell me in the chats. Let me first of all check it from my phone. Is the screen perfectly clear? I think yes, it's absolutely clear. Yeah? Yes, all the classes are absolutely free of cost. You need not to worry, right? You need not to worry about that. Perfect, guys. So let's get going then. Let's get started. Let's not waste further any sort of time. And the ones who have not liked the session yet, I would want you guys to smash that like. And the ones who have not subscribed to the channel yet, please do subscribe to the channel as well, so that you remain updated about all the sessions which are going to take here in this particular Achievers batch, right? Which is absolutely free for all. Okay, the ones who cannot afford the paid batches, this particular batch is for all of you. The quality content which you are going to get here, trust me, that will be unmatchable. Okay, perfect, guys. So let's get going. Let's get started with the chapter mole concept. This is the first chapter of our class 11th chemistry. So let's get going with this. All right, people. So the first and the basic topic with which we start this particular chapter. The first and the basic topic with which we start this chapter, that is atomic mass. Okay, that is atomic mass. Now, first of all, how do we exactly define the term atomic mass? My dear students, let me quickly write one of the simplest definition of the term atomic mass. One of the simplest definitions. Atomic mass is basically defined as the mass of one atom of an element. Atomic mass is basically defined as the mass of one atom of an element. Now, from this particular statement only, I'm pretty much sure all of you would have got the idea of what this atomic mass exactly is all about. Atomic mass, it is basically defined as the mass of one atom of an element. For example, if I ask you, what is the atomic mass of oxygen? That means I'm actually asking you, what is the mass of one atom of oxygen? If I ask you, what is the atomic mass of nitrogen? What does that mean? That actually means I'm asking you, what is the mass of one atom of, let's say, the element? If I, for example, ask you, what is the atomic mass of sodium? What does that mean? That means I'm asking you, what is the mass of one atom of sodium? Right? If I ask you, what is the atomic mass of boron? That means I'm asking you, what is the mass of one atom of boron? So basically, atomic mass, it is defined as the mass of one atom of an element. Nothing more than that. This is the simplest definition of the term atomic mass. This is the simplest definition of the term atomic mass. If I ask you, what is the atomic mass of fluorine? What does that mean? That means I'm asking you, what is the mass of one atom of fluorine? As simple as that, people. As simple as that. So this is the basic definition of the term atomic mass. In order to get the real feel of atomic mass, in order to get the exact meaning of the term atomic mass, right, we need to learn few basics over here. And what is that basics which you need to know? Let's try to understand that one by one. Try to understand, people, what exactly I'm going to do. For example, I'm going to take few objects over here. My dear students, for example, these are the three objects which I've taken over here. I'm going to make you understand this in a very simplest manner. Try to understand what exactly I'm going to do. So, my dear students, I have taken three objects over here. For example, I'm assuming the weight of the first object. Let's say it is 5 kilograms. Let's say the weight of the second object, it is 10 kilograms. Let's say the weight of the third object, it is 20 kilograms. So how many objects have I taken here? I've taken three objects. Weight of the first object, that's 5 kilograms. Weight of the second object, that is 10 kilograms. Weight of the third object, that is 20 kilograms. First of all, this 5 kg over here, I'm going to break it as 5 multiplied by 1 kg. I can do that. 5 multiplied by 1 kg comes out to be 5 kg only. Similarly, this 10 kg over here, I'm going to break it as 10 multiplied by 1 kg. And similarly, this 20 kg over here, I am going to break it as 20 multiplied by 1 kg. Now the point is, why did I break this 5 kg as 5 multiplied by 1 kg? Why did I break this 10 kg as 10 multiplied by 1 kg? In the similar way, why did I break this 20 kg as 20 multiplied by 1 kg? What is the logic behind that? My dear students, try to understand what exactly I'm going to say. This first object whose weight is 5 kilograms, what does it mean? It means that this particular object, it is 5 times heavier than 1 kilogram. Similarly, this particular object, it is 10 times heavier than 1 kilogram. Similarly, this particular object, it is 20 times heavier than 1 kilogram, right? Yes, I'll say this first object is 5 times heavier than 1 kilogram. Second object is 10 times heavier than 1 kilogram. Third object is 20 times heavier than 1 kilogram, right? For example, my weight is 75 kilograms. What does that mean? That means I am 75 times heavier than 1 kilogram, right? So, my dear students, can I say I am comparing the weights of different objects? Can I say I am comparing the weights of different objects with this 1 kilogram over here? Yes, I am comparing the weights of different objects with this 1 kilogram over here. Okay? So, 1 kilogram is the one with which I am comparing the weights of different objects. So, this 1 kilogram here, I'll be calling it as reference, right? I'll be calling it as reference. I'll be calling it as the standard. I will be calling it as the standard with which we are comparing the weights of different objects. But my dear students, this 1 kg, it is your standard basically in physics. It is your standard in physics with which you compare weights of different objects, right? This 1 kg is the standard in physics with which we compare weights of different objects. Since in chemistry, we deal with atoms, we deal with molecules, we deal with ions. So my dear students, don't you think in chemistry also, we should have a standard like this 1 kg? Don't you think in chemistry also? Don't you think in chemistry also we should have a standard like this 1 kg so that we can compare the weights of different atoms or molecules or ions with that particular standard? Yes. In physics, our standard is 1 kg with which we are comparing the weights of different objects. Correct? In chemistry, since we deal with atoms, we deal with molecules, we deal with ions. In chemistry, we should have a standard like this 1 kg so that we can compare the weights of different atoms, molecules, or ions with that standard. Yeah? Now the point is, what is that standard in chemistry? What is that reference in chemistry with which we compare the weights of different atoms or molecules? Now, my dear students, let's try to make that standard over here. 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 See guys, in order to make that standard, what I'll be doing exactly, I will be taking a carbon 12 atom. I will be taking a carbon 12 atom. For example, this is your carbon 12 atom. For example, this is your carbon 12 atom. My dear students, the carbon 12 atom which I've taken over here, what exactly am I going to do? I am going to divide this carbon 12 atom into 12 equal parts. I divided this carbon 12 atom into 12 equal parts. After dividing this carbon 12 atom into 12 equal parts, if I just take the small part over here, can I say the mass of this small part is nothing but it is the 1/12 of the mass of carbon 12 atom? Yes, I can say that. So what did I do first of all? I took a carbon 12 atom. I divided the carbon 12 atom into 12 equal parts. After dividing the carbon 12 atom into 12 equal parts, I took a small part over here. And I'm telling you, the mass of this small part is nothing but it is 1/12 of the mass of carbon 12 atom. Now, my dear students, remember this 1/12 of the mass of carbon 12 atom, from now onwards, you'll be calling it as 1 AMU, or you will be calling it as 1 U, or you will be calling it as 1 D. Okay? This 1/12 of the mass of carbon 12 atom, you'll be calling it as either 1 AMU, or you'll be calling it as 1 U, or you will be calling it as 1 D. Now the point is, this AMU, let me tell you, it stands for the atomic mass unit. This U over here, it stands for the unified mass. And this D over here, it stands for the term Dalton, right? It stands for Dalton. Now, people, remember a few things which I'm going to tell you right now. What scientists exactly did, they used a technique called as mass spectrometry. They used a technique called as mass spectrometry, with the help of which, what they exactly did, they calculated the mass of whole carbon atom. They calculated the mass of whole carbon 12 atom. And let me tell you, the mass of entire carbon 12 atom, it came out to be 1.99 into 10 raised power minus 23 grams. So a technique called as mass spectrometry was used, and the mass of entire carbon 12 atom was calculated. It was found out to be how much? It was found out to be 1.99 into 10 raised power minus 23 grams. Now, my dear students, if I ask you something, one simple statement, if I ask you, if you know the mass of entire carbon 12 atom, if you know the mass of entire carbon 12 atom in grams, okay, can you tell me what is going to be the mass of this shaded part in grams? Right? See, the mass of entire carbon 12 atom is going to be 1.99 into 10 raised power minus 23 grams. Right? This is the mass of entire carbon 12 atom. If you just divide it with the number 12, you'll be getting the value exactly as 1.66 into 10 raised power minus 24 grams. Okay. So what about this particular term? What is this mass? This is not the mass of the whole carbon 12 atom. This is the mass of the shaded part in grams. This is the mass of the shaded part in grams. Right? So basically, I'm over here trying to make a standard in chemistry with which I shall be comparing the masses of different atoms or molecules. In order to make that standard, I took a carbon 12 atom. I divided the carbon 12 atom into 12 equal parts. After dividing the carbon 12 atom into 12 equal parts, I took a small part over here. And the mass of this small part, it is nothing but 1/12 of the mass of carbon 12 atom, which from now onwards, you'll be calling it as 1 AMU, or you will be calling it as 1 U, or you will be calling it as 1 D. AMU stands for atomic mass unit, U stands for unified mass, and D stands for Dalton. Now, what scientists did, they used a technique called as mass spectrometry, with the help of which the mass of whole carbon 12 atom was calculated. How much it came out to be? It came out to be 1.99 into 10 raised power minus 23 grams. Now the point. If you know the mass of whole carbon 12 atom, you can calculate the mass of this shaded part as well. What you simply need to do, you just need to divide this number by 12. You'll be getting exactly the value as 1.66 into 10 raised power minus 24 grams. Now, if I ask you, 1.66 into 10 raised power minus 24 grams. Is this the mass of entire carbon-12 atom? No, this is the mass of the shaded part over here in grams. I believe this is clear to everyone. Yeah, I believe this is clear to everyone. Yes? Now, people, whatever I told you till now, I'm going to summarize each and everything in one simple statement, and you are going to remember that statement from now onwards. What is that statement? Try to understand. I'm writing 1 AMU, which is also what you call as 1U, which is also what you call as 1D. How did we define it? We defined it as 1 by 12th of, the mass of carbon-12 atom, right? Okay. Mass of carbon-12 atom, you know, right? That was 1.99 in 10 raised power minus 23 grams divided by 12. The value came out to be 1.66 into 10 raised power minus 24 grams, right? Yes? Right, people? Now, try to understand what exactly I'm going to say. For example, I'm writing 1.5 over here. Let's say I'm writing 1.5. Can I write 1.5 as 3 by 2? Yes, 1.5 is nothing but 3 by 2. Correct? Right? For example, I'm writing 3.33. What is 3.33? Can I write it as n by 3? Yes, we can do that. Similarly, this particular number, 1.66 into 10 raised power minus 24, it can be written as 1 divided by Avogadro's number as well. 1 divided by Avogadro's number. Avogadro's number you all must be knowing, 6.022 into 10 raised power 23. 1 by 6.022 into 10 raised power 23, when you solve it, its value comes out to be exactly this much. Its value exactly comes out to be this much. That is the reason why instead of 1.66 into 10 raised power minus 24, I wrote 1 divided by Na grams. And this is the statement which I would want every one of you to remember from now onwards, because this is super important, guys. I'll be frequently using this particular statement from now onwards, right? Who is continuously spamming the chats? Let me block them just a second, people. There are a lot of people coming in. I feel they have been sent by some other platforms. How do we block them? Hide user. Yes, done and dusted, yeah? Okay. I don't know how much money they got from the other platforms. So come and spam here. It's okay. You should have told me. I would have given you more money. Okay. Look here now. 1 AMU, which is what you call as 1U, which is what you call as 1D. How did we define it? 1/12 of the mass of carbon-12 atom, which came out to be 1.66 into 10 raised power minus 24 grams, and which can be written as 1 divided by Na grams. Okay. Now, people, try to understand what exactly I'm going to tell you now. Okay. I'm going to write few statements which will make your terminology clear. I'm writing a term, for example, atomic mass of oxygen. Atomic mass of oxygen. If I ask you what is meant by the term atomic mass of oxygen, if I ask you what is meant by the term atomic mass of oxygen, let me tell you, it is nothing. As per the definition, atomic mass of oxygen means the mass of one atom of oxygen. Atomic mass of oxygen means the mass of one atom of oxygen. And I believe all of you must be knowing, right? You all must be knowing atomic mass of oxygen is nothing but 16 AMU, right? 16 AMU. Now the point is, what is meant by the 16 AMU? In order to understand the meaning of 16 AMU, I just need to break it as 16 multiplied by 1 AMU. Yes. And instead of 1 AMU, you can write 1 by 12th of the mass of carbon-12 atom, right? Instead of 1 AMU, you can write 1.66 into 10 raised power minus 24 grams. Instead of the same 1 AMU, you can write 1 divided by Na grams as well. Okay. Now let's try to understand the meaning of all these terms over here. People, atomic mass of oxygen, what does that mean? That means I'm talking about the mass of one atom of oxygen. And the mass of one atom of oxygen came out to be 16 AMU. What does it mean? It means that one atom of oxygen is 16 times heavier than 1 AMU. You got it? One atom of oxygen is 16 times heavier than 1 AMU. Right? Similarly, one atom of oxygen is 16 times heavier than 1 by 12th of the mass of carbon-12 atom. It is 16 times heavier than 1 by 12th of mass of carbon-12 atom. Yeah? Right? And my dear students, if you ask me, what about this particular term? What about this particular term? I'll say, this is the mass of this whole term. It is the mass of one oxygen atom in grams. This is the mass of one oxygen atom in grams. Even this particular term over here, which is expressed in terms of Avogadro's number, I'll say this whole term also is going to be the mass of one oxygen atom in grams. This is the mass of one oxygen atom in AMU. This is the mass of one oxygen atom in grams. Even this is the mass of one oxygen atom in grams. I believe this is clear to everyone. Yeah? Let me write one more statement so that this particular term, it becomes absolutely clear to every one of you. For example, I'm writing atomic mass of nitrogen. Atomic mass of nitrogen. Now, if I ask you as per definition, what does it mean? If I ask you as per definition, what does it mean? You'll simply tell me atomic mass of nitrogen means the mass of one atom of nitrogen. Atomic mass of nitrogen means the mass of one atom of nitrogen. And I believe you all will be knowing that the atomic mass of nitrogen is nothing but 14 AMU. It is nothing but 14 AMU. Now, what is the meaning of this 14 AMU? In order to understand the meaning of this 14 AMU, what do I need to do? I need to break this 14 AMU, and I will be breaking it as 14 multiplied by 1 AMU. Correct? Instead of 1 AMU, I can write 1 by 12th of the mass of carbon-12 atom. Instead of 1 AMU, I can write 1.66 into 10 raised power minus 24 grams. Instead of 1 AMU, I can write 1 divided by Avogadro's number, and the units will be in grams. Now, if I ask you what is the meaning of all this stuff, if I ask you what is the meaning of all these stuff, see, I defined the term atomic mass of nitrogen. What does it mean? It means I'm talking about the mass of one atom of nitrogen. And you got to know one atom of nitrogen. It is 14 times heavier than what? Heavier than 1 AMU. It is 14 times heavier than 1/12th of the mass of carbon-12 atom. I would say this is the mass of one nitrogen atom in grams. Even this is also the mass of one nitrogen atom in grams. Yes? Right, people? Right? So can I say atomic mass is nothing? It is just a number. Atomic mass is a number which tells us how many times an atom of an element is heavier than 1 AMU. What does that mean? See, over here you got to know one atom of oxygen is 16 times heavier than 1 AMU. You got to know one atom of nitrogen is 14 times heavier than 1 AMU. So basically, atomic mass is telling us how many times an atom of an element is heavier than 1 AMU, right? So let me quickly write its definition, its statement, and what the statement exactly is all about. Hey guys, mark this definition with me because this is important. So I would say atomic mass. I would say atomic mass of an element. Atomic mass of an element gives an information about how many times an atom of an element is heavier than 1 AMU. Is heavier than 1 AMU. I believe this particular definition is super clear to everyone. If this is super clear to everyone, let me know once in the chats whether yes or no. Quickly. Quickly, people. Quickly, everyone. If this is clear to everyone, let me know in the chats with yes or no so that I'll get to know whether you got the concept or not. Yes? Perfect. I would want everyone to let me know. Everyone in the chats. Everyone in the chats. Yeah? Guys, I want everyone to let me know in the chats. Please, quickly, be active in the chats as well. Perfect. Perfect, people. Perfect. Now, after getting to know what kind of information atomic mass gives us, let me tell you a few more things over here. See, guys. For example, I'm taking an element nitrogen. I took an element nitrogen. And if you look carefully, nitrogen over here, I took in which form? I took in atomic form. This is the atomic form of nitrogen, N. I'm not writing N2, I'm just writing N. This is the atomic form of nitrogen. Now, people, related to nitrogen, I'm going to write few terminologies. The first term I'm writing 14 AMU. Second term, I'm only writing 14. The third term, I'm writing 14 multiplied by 1.66 into 10 raised power minus 24 grams. These are the three terms which I wrote related to nitrogen. Let me tell you the first term. I will be calling as simply atomic mass of nitrogen. The first term I'll be calling as atomic mass of nitrogen. My dear students, the second term, which is without the units, which is just the number 14. This 14 over here, I will be calling it as the relative. I will be calling it as the relative atomic mass of nitrogen. And this whole term, I will be calling this as the actual mass of nitrogen. I will be calling this as the actual mass of N, right? So remember these three terms. One with AMU, one without any units, one in this particular format, right? Okay. For example, if I generalize it, my dear students, I'm taking an element X. Which is in atomic form. Let me write three terminologies related to X. First term, I'm writing M AMU. Second term, I'm only writing M. The third term, I'm writing M multiplied by 1.66 into 10 raised power minus 24 grams. If I ask you what is the meaning of these three terms, quickly, the first term over here, what do you call this as? You call this as the atomic mass of X. You call this as the atomic mass of this X. This M over here without the units, you will be calling this as the relative atomic mass of X. Okay. And this particular term, you will be calling this as the actual mass of X. I hope this is super clear to everyone. Right? Now, people, one simple and basic question so that I'll just understand, get to know whether you got the concepts or not. For example, I'm writing one basic, simple question so that I'll understand whether you got it or not. Okay? One simple thing I'm writing. I'm asking you to calculate the mass of 10 nitrogen atoms. Calculate the mass of 10 nitrogen atoms. Number 1, in AMU. Number 2, in grams. Calculate the mass of 10 nitrogen atoms in AMU, in grams. These are the two questions, right? So first of all, I need to calculate the mass of 10 nitrogen atoms. Before calculating the mass of 10 nitrogen atoms, tell me, what is the mass of one nitrogen atom? You know, the mass of one nitrogen atom, that means we are talking about the atomic mass of nitrogen, which is nothing but 14 AMU. This is the mass of one nitrogen atom in AMU. So if this is the mass of one nitrogen atom in AMU, the mass of 2 nitrogen atoms will be multiplied by 2, 3 nitrogen atoms multiplied by 3, 10 nitrogen atoms will be multiplied by 10. So it will be 14 multiplied by 10 AMU, which will be, the answer of the first question is going to be 140 AMU. This is the mass of 10 nitrogen atoms in what? In AMU. This is the mass of 10 nitrogen atoms in AMU. Now, what will be the mass of 10 nitrogen atoms in grams? See, we got to know this is the mass of 10 nitrogen atoms in AMU, right? Can you write the same thing as 140 multiplied by 1 AMU? And instead of 1 AMU, you can just write 1.66 into 10 raised power minus 24 grams. So I will say this entire term, this is the mass of 10 nitrogen atoms in grams. This is the mass of 10 nitrogen atoms in AMU. This is the mass of 10 nitrogen atoms in what? In grams. I believe this is all clear. I believe this is all clear. Well, the same thing over here, you can write in this format as well. 140 multiplied by. Instead of this particular term, you can write 1 divided by Avogadro's number. Units are going to be in grams. Anything works. Either you'll write the answer in this format or in this format. Yeah? I hope you got the first term. That was our atomic mass. Okay? Now, people, let's try to define one more term, that is molecular mass. Let's try to define one more term, that is molecular mass. How do we exactly define the term molecular mass? See, in simple terminologies, molecular mass is nothing. It is defined as the mass of one molecule. It is defined as the mass of one molecule. Or it is defined as the sum of atomic masses. The sum of atomic masses of all the elements present in a molecule. It's very simple and basic. Let's try to understand it carefully. Let's try to understand it carefully. My dear students, for example, if I take water into consideration, if I ask you what is the molecular formula of water, you know it. It is H2O. For example, I'm asking you to calculate the molecular mass of water. What does that mean? For example, I'm asking you to calculate the molecular mass of water. What does that mean? That means I'm asking you to calculate the mass of one molecule of water. That means I'm asking you to calculate the mass of one molecule of water. And how do you calculate it? How do you calculate it? As per this definition, sum of atomic masses. In water, you have got two elements, hydrogen and oxygen, right? First of all, what is the atomic mass of hydrogen? It's 1 AMU. How many hydrogen atoms do you see here? 2. What is the atomic mass of oxygen? 16 AMU. How many oxygen atoms do you see? 1. So when you solve this, this value comes out to be 18. Now, you can either write AMU, or you can write U, or you can write D. But preferably, we write U over here. Okay? Preferably, we write U instead of AMU. Perfect? Right? Now, people, what did we get? We got the molecular mass of water as 18U. Now, if I ask you, or if you ask me, what is meant by this 18U? In order to understand the meaning of this 18U, I need to break it into two parts. I'll write 18 multiplied by 1U. Yeah? Similarly, this 1U, instead of 1U, you can write 1 by 12th of the mass of carbon-12 atom. You can do that. Instead of 1U, you can write 1.66 into 10 raised power minus 24 grams. Right? And instead of same 1U, you can write 1 divided by Na. 1 divided by Avogadro's number in grams. Perfect? So, what is the meaning of all these terms which I have mentioned over here? My dear students, I just wanted to calculate the molecular mass of water. I just wanted to calculate the mass of one molecule of water. And if you look carefully, the mass of one molecule of water came out to be 18U. That means one molecule of water is 18 times heavier than 1U. One molecule of water is 18 times heavier than 1/12th of the mass of carbon-12 atom. This is the mass of one molecule of water in grams. Even, this is also the mass of one water molecule in grams. As simple as that. As simple as that. Right? Right, people? I believe this is clear to everyone. I'll take one more example, which will make this super clear. I'll take one more example, which will make it super clear. My dear students, for example, if I take glucose into consideration. Glucose, right? For example, I'm asking you to calculate the molecular mass of glucose. Let's say I'm asking you to calculate the molecular mass of glucose. What does that mean? What am I exactly asking you? I'm exactly asking you to calculate the mass of one molecule of glucose. Now the point is, how do you do that? How do you do that? What is the molecular formula of glucose? C6H12O6, right? First of all, when it comes to the glucose, in glucose, how many elements do you see? 3 elements: carbon, hydrogen, oxygen. Now people, what is the atomic mass of carbon? You know it, 12 AMU. How many carbon atoms do you see? 6 carbon atoms. What is the atomic mass of hydrogen? 1 AMU. How many hydrogen atoms do you see? 12. What is the atomic mass of oxygen? 16 AMU. How many oxygen atoms do you see? 6. When you solve this, the value comes out to be 180. You can write AMU, you can write U, you can write D. The choice is all yours. But preferably, what do we write? Preferably, we write U. Okay. Now, my dear students, what is the meaning of this 180U over here? See, in order to understand the meaning of 180U, I'll just break it as 180 multiplied by 1U. Okay. And instead of 1U, you can write 1 by 12th of the mass of carbon-12 atom. Instead of 1U, you can write 1.66 into 10 raised power minus 24 grams. Instead of 1U, you can write 1 divided by Avogadro's number in grams. Okay. So tell me the meaning of all these terms over here. I just wanted to calculate the molecular mass of glucose. I just wanted to calculate the mass of one molecule of glucose. The mass of one molecule of glucose came out to be 180U, which means that one molecule of glucose is 180 times heavier than 1. It is 180 times heavier than 1 by 12th of the mass of carbon-12 atom. Right? I would say this is the mass of one glucose molecule in grams. Even this is the mass of one glucose molecule in grams. Right? So now if I ask you, what kind of information molecular mass is giving us? Right? If I ask you what kind of information this molecular mass is giving us. See, over here you got to know water is 18 times heavier than 1U. And over here you got to know glucose is 180 times heavier than 1U. So can I say molecular mass is giving us the information about how many times a molecule is heavier than 1U? Yeah? Can I say that? Let me know in the chats. Let me know in the chats. I'll write molecular mass. Molecular mass gives an information. Molecular mass gives an information about how many times a molecule is heavier than. A molecule is heavier than. Either you can write 1 AMU or you can write 1 U or you can write 1 D. The choice is all yours. Let me know once in the chats if this particular statement is clear to everyone. Say yes or no in the chats. I would want everyone to let me know. I would want everyone to let me know in the chats if this stuff is clear till here. Okay? Right, people? Now, one more thing. My dear students, for example, I'm taking nitrogen in the form of N2 over here. For example, let's say I took nitrogen in the form of N2. So that means I took nitrogen in which form? Atomic form or molecular form? This is basically the molecular form of nitrogen. This is basically the molecular form of nitrogen. Okay? Now, people, let me write few terminologies related to this N2 over here. The first term, I'm writing 28U. 14 into 2 is 28. So 28U. Second term, I'm just writing 28. Third term, I'm writing 28 multiplied by 1.66 into 10 raised power minus 24 grams. Now, if you ask me, what is the meaning of these three terms over here? What is the meaning of these three terms over here? It means that this 28U, what do I call this as? Should I be calling this as atomic mass of nitrogen? No way. I took nitrogen in molecular form. So this 28U, I will be calling it as the molecular mass of nitrogen. Okay. This 28 I won't be calling this as the relative atomic mass of nitrogen. I will be calling this as the relative molecular mass of nitrogen. I will be calling it as the relative molecular mass of nitrogen. And this particular term over here, this is something which I'll be calling as the actual mass of N2. This I'll be calling as the actual mass of N2. Right? This I'll be calling as the actual mass of N2. I believe it's super clear to everyone. Yeah? I believe it's super clear to everyone. So if I generalize it, people, for example, try to understand. Right here I'm writing O. And over here I'm writing O2. Try to understand all these terms. Here I have taken oxygen in which form? Here I have taken oxygen in atomic form. And in the second case, I have taken oxygen in which form? I have taken oxygen in molecular form. That is the difference. Atomic form and molecular form. Right? Now people, I'm writing few things. First term, I'm writing 16 AMU. Second term, just 16. Third term, 16 multiplied by 1.66 into 10 raised power minus 24 grams. Over here, I'm writing few terms like 32U. Then I'm writing 32. Then I'm writing 32 multiplied by 1.66 into 10 raised power minus 24 grams. Now, if you ask me what is the meaning of all this stuff, you should be in a position to let me know the meaning of all this stuff. This 16 AMU, my dear students, this is what you will be calling as the atomic mass of oxygen, right? This is something which you call as a relative atomic mass of oxygen. This is something which you call as the actual mass of O. The actual mass of O. Now, what about these terms over here? This is what you call as the molecular mass of oxygen. Molecular mass of oxygen. This is what I'll call as a relative molecular mass of oxygen. And this is something which you will be calling as the actual mass of what? Of O2. If all these things are clear till here, let me know once in the chats. Let me know once in the chats if all these things are clear till here. Everyone, people, everyone in the chat. Everyone in the chats. Everyone in the chats. Quickly. One simple question I've given you. One simple question I've given you. Calculate the mass of 10 ammonia molecules in U, second, in grams. Guys, you should be in a position to answer this question. Yeah? You should be in a position to answer this question. First of all, if you analyze one ammonia molecule, right? First of all, what is the molecular mass of ammonia? 14 for nitrogen plus 1 for hydrogen multiplied by 3. So 14 plus 1 into 3 is 17, right? So if I mention ammonia over here, if I want to calculate its molecular mass, nitrogen is going to be 14 multiplied by, there is 1 nitrogen atom. Hydrogen is going to be 1. There are 3 hydrogen atoms. The value comes out to be 17U. So this is the molecular mass of ammonia, right? I would say this is the mass of 1 molecule of ammonia in U. If this is the mass of 1 molecule of ammonia in U, what will be the mass of 10 molecules of ammonia in U? I'll be multiplying this term with 10, right? So 17 multiplied by 10 comes out to be 170U. This is the mass of 10 ammonia molecules in U, right? Now, what will be the mass of 10 ammonia molecules in grams? This 170U, you can break it as 170 multiplied by 1U. And instead of 1U, you can write 1.66 into 10 raised power minus 24 grams. So this is this complete term. This is the mass of 10 ammonia molecules in grams. Or you can write it like this as well. 170 multiplied by 1 upon Na grams. Right? I believe this stuff is absolutely clear to every one of you. And over here, I just want you guys to take a note of one quick statement. I just want you guys to take a note of one quick statement over here. Remember, my dear students, on changing the scale, this statement I would want everyone to remember directly, right? On changing the scale, what is meant by that? What is the scale which we have chosen? We have chosen the scale as 1U is equal to 1/12 of mass of carbon to atom, right? That is our scale. That is the conventional scale. That is the scale which we have chosen. 1 AMU we have defined as 1/12 of mass of carbon to atom. If you change the scale, if you say 1U is not 1/12, it is 1/6 of mass of carbon to atom. It is 1/24 of mass of carbon to atom. So that means you are changing the scale there. So my dear students, on changing the scale, remember actual mass of the substance. On changing the scale, actual mass of the substance. Actual mass of the substance does not change. When you change the scale, it's going to be the actual mass of the substance which does not change. Remember this particular statement, it can be asked directly as a theoretical question. So when you change the scale, what will happen to the actual mass of the substance? Actual mass of the substance remains unchanged. It remains unchanged. Yeah? So people, whatever stuff I told you till now, let's try to utilize this stuff in the form of questions. Okay? In the form of questions. This is one very common question. This is one very, very, very common question. Let's try to solve this question. Let's see what the question says. As far as this particular question is concerned, if 1U is defined as 1/24 of the mass of carbon to atom, what will be the molecular mass of carbon dioxide on new scale? You can modify this question. Also calculate the actual mass of carbon dioxide. Also calculate the actual mass of carbon dioxide. These are the two questions which I have. Now, how do I solve them? How do I solve them? Let's try to understand. My dear students, if I ask you, how did we define 1U? How did we define 1U? Just a second, guys. Let me turn the electricity on for some time. Right? Very hot here now. Okay, just a second. All right, look here now. So, how did we define 1U? How did we define 1U? We defined 1U as, if you remember, we defined it as 1/12 of the mass of carbon to atom. This is how we defined it. This is how we defined it, right? 1U, we defined it like this. 1/12 of the mass of carbon to atom, right? As per the question, how they are defining 1U? As per the question, they are defining 1U as 1/24th. They are defining 1U as 1/24th of the mass of carbon to atom. This is how they are defining 1U as per the question. So, this is something I will be now calling as 1U dash. This is something which I'll be calling as 1U dash. Correct? 1U dash. Now, people, this 1U is equal to 1/12 of mass of carbon to atom. This is the scale which we have chosen. So, you'll be either calling it as the conventional scale, or you can directly call it as the old scale, which we have chosen. And this is the scale which is given to us as per the question. This is the new scale. Let me call this as equation 1. Let me call this as equation 2. Right? The first thing always, when you are given with this sort of equation, the first thing always which you shall be doing, what is that? You'll be dividing these two equations. If you divide these two equations, 1/2, it will be U divided by U dash. U divided by U dash is equal to mass of carbon 12 cancel. In the numerator, you are left with 1/12. In the denominator, you are left with 1/24. So, you got to know U divided by U dash is nothing but 2. Therefore, U is equal to 2 times U dash. Therefore, U is equal to 2 times U dash. U is equal to 2 times U dash. So, whenever this sort of equation comes, the first step always is to get the relation between old U and new U. The first thing is always to get the relation between relation between u and u dash. This is my first step always. Now, the second step. The second step, people. What is the second step over here? Try to understand carefully what is the second step. As per the question, we are supposed to calculate the molecular mass of carbon dioxide. Let me first of all calculate molecular mass of carbon dioxide the way we have done it till now. So molecular mass of carbon dioxide will be equal to sum of atomic masses. Carbon, it is 12 multiplied by 1 carbon atom. Oxygen, it's 16 multiplied by 2 oxygen atoms. When you solve this, the value comes out to be 44U. The value comes out to be 44U. Now people, this 44U. This 44U. I would say this 44U, this is the molecular mass. This is the molecular mass of carbon dioxide. As per which scale? As per old scale. As per old scale, right? But as per the question, am I supposed to calculate the molecular mass of carbon dioxide as per old scale? No. I'm supposed to calculate the molecular mass of carbon dioxide as per new scale. That means I am not supposed to calculate the molecular mass of carbon dioxide in terms of U. I am supposed to calculate it in terms of U dash. Right? So, how do I do it now? This 44U, I can write like this, 44 multiplied by 1U. And instead of 1U, people, instead of 1U, you can write 2 times U dash. The value comes out to be 88U dash. So, you got to know, this is now the molecular mass of carbon dioxide as per which scale? As per old scale or new scale? This is the molecular mass of carbon dioxide as per new scale. This was the molecular mass of carbon dioxide as per old scale, right? Okay. So, our first question is done and dusted. Second question. Second question. Calculate the actual mass of carbon dioxide. I told you already on changing the standard. It is the actual mass of the substance that does not change. Right? What was the actual mass of carbon dioxide earlier? Actual mass of carbon dioxide was this much, 44 multiplied by this term, right? This was the actual mass of carbon dioxide. It will remain unchanged. It will always remain the same. If you want to change the standard to anything, actual mass of the substance does not change. Okay, I believe this sort of a question you can easily kill from now onwards. If you look at this question, just tell me yes or no in the chats whether you can solve this question on your own or not. Quickly. Just tell me yes or no in the chats whether you can solve this particular question on your own or not. Quickly, people. Do not take a lot of time. Just say yes or no in the chats. Just say yes or no in the chats. If you can solve this sort of a question on your own from now on. Yeah? Now, you need to be super fast in order to solve this question. You're not supposed to take the amount of time which you took in order to solve the first question. No, you have to be super fast. Very fast you have to be, guys. Say, how did we define 1U? We defined it as 1 by 12 of what? We defined it as 1 by 12 of the mass of carbon-12 atom. And as per the question, how they are defining 1U, which I'm calling as 1U dash. They are defining it as 1 by 6th. 1 by 6th of what? 1 by 6th of the mass of carbon-12 atom. What is my first step always? My first step always is to divide these two equations. When I divide these two equations, equation 1 divided by equation 2 will come out to be this term cancel. 1 by 2 in the 12 in the numerator, 1 by 6 in the denominator. So U divided by U dash will come out to be 1 by 2. Therefore, U is nothing but U dash by 2. So my first step is done. I got the relation between U and U dash. I got the relation between U and U dash. Now, what is my second step? What is my second step, people? I got the relation between U and U dash. Now, let's try to calculate everything as normal. Molecular mass of NH3. Tell me what is the molecular mass of NH3 as per our scale. How do we do it? How do we do it, people? Nitrogen, 14. How many nitrogens? 1 nitrogen atom. Hydrogen, 1 AMU. 3 hydrogen atoms. The value comes out to be 17U. So this is the molecular mass of nitrogen as per our scale, as per old scale. But are we going to calculate it? Are we supposed to calculate it in terms of U? No, we are supposed to calculate it in terms of U dash. So you can write it as 17 multiplied by 1U. And instead of 1U, you can write U dash by 2. Which comes out to be 8.5 U dash. So what is this 8.5 U dash? This is the molecular mass of NH3 as per the scale which is given to me in the question. This is the molecular mass of NH3 as per old scale, right? And this is the molecular mass of NH3 as per the new scale. Now, they're also asking you to calculate the actual mass of NH3. And you know, on changing the standard, it's the actual mass which does not change. So actual mass of NH3 will be same 17 multiplied by 1.66 into 10 raised power minus 24 grams. This is the actual mass of NH3, right? Which is not going to change no matter what kind of standard you are going to make. If every single thing is clear till here, let me know once in the chats with some thumbs ups quickly. Till then, I can have some water. Is it clear? Is all of this clear till now? I want you to let me know in the chats quickly if every single thing is clear till now. Quickly, people, everyone. Everyone means everyone. Everyone means everyone. There are more than 200 people watching me right now, so there should be more than 200 thumbs ups in the chats. That's how I'm going to understand whether you guys got it or not. Perfect. So, by the way, can you let me know in the chats, like, where are you guys from? Which state you belong to? I just want to know. I just want to know which state you guys belong to. I just want to know that. Quick. Quick. I just want to know which state you guys belong to. See, now the chats are going to run. See the way the chats are going to run now. I can see majority from Tamil Nadu, Karnataka, Andhra, Madhya Pradesh, AP, Kerala, Manipur, Srinagar, Kashmir, all right, Mizoram, that's great, Telangana. So students across the country are watching, right? Perfect, guys. All right. So let's move on then. All right. Perfect. Got it. Look here now. Yes, JE aspirants are also most welcome, right? JE aspirants are most welcome too. All right. The next terminology, my dear students, that is going to be the molar mass. Okay. This is again one super important term which you need to know. So how do we define the term molar mass? Before defining the term molar mass, I'm going to write the same statement again, which I gave you a few minutes back, which was like this. 1 AMU, which is what you call as 1U, which is what you call as 1D. How did we define it? We defined it as 1/12 of the mass of carbon-12 atom, which came out to be 1.66 into 10 raised power minus 24 grams. And in terms of Avogadro's number, I wrote it as 1 divided by Na grams. Yeah? This is the statement which I gave you already. Okay? Now we will try to understand. Before defining the term molar mass, there are few basic things which I would want every one of you to know right now. What is that? See, guys. If I write a statement, 1 mole of a substance. 1 mole of a substance. What does it mean? 1 mole of a substance. Mole is just like a unit. You know it. Mole is just like a unit, like kg, like liters, right? Mole is just a unit. Okay? So first of all, 1 mole of substance. Remember it from now onwards. 1 mole of substance, it always contains 6.022 into 10 raised power 23 particles of the substance. Whenever I say that I have got 1 mole of a particular substance, that means I have got 6.022 into 10 raised power 23 particles of the substance. For example, if I say that I have got 1 mole of carbon, if I say that I've got 1 mole of carbon, what does that mean? That means I've got 6.022 into 10 raised power 23 atoms of carbon. Right? As simple as that. If I say that I've got 1 mole water, what does that mean? What does that mean? That means I've got 6.022 into 10 raised power 23 water molecules. Water molecules. Yes. For example, if I say I have got 1 mole of 1 mole of O di negative. 1 mole of O di negative. What does that mean? That means I've got 6.022 into 10 raised power 23 ions of O di negative. Ions of O di negative. So in short, my dear students, 1 mole of a substance, it contains 6.022 into 10 raised power 23 particles. As simple as that. If I say I've got 1 mole of marker, what does that mean? That means I've got 6.022 into 10 raised power 23 markers. Yes? Now, if you ask me what is molar mass? What is molar mass? How do we define the term molar mass? My dear students, let me tell you, molar mass is defined as, it is defined as the mass of 1 mole of a substance. It is defined as the mass of 1 mole of a substance. It is either expressed in grams, it is either expressed in grams, or you can say grams per mole. Let's try to understand this. Molar mass is nothing but mass of 1 mole of substance. My dear students, for example, I'm asking you, what is the molar mass of carbon? Let's say I'm asking you, what is the molar mass of carbon? If I ask you what is the molar mass of carbon, that means what am I exactly asking you? Molar mass of carbon. That means I'm asking you the mass of 1 mole of carbon. If I ask you what is the molar mass of water, that means I'm asking you what is the mass of 1 mole of water. If I ask you what is the molar mass of this marker, that means I'm asking you what is the mass of 1 mole of the marker. Right? As simple as that. So, molar mass of the substance is nothing, it is just the mass of 1 mole of the substance. The mass of 6.022 into 10 raised power 23 particles. As simple as that. Okay? For example, I'm asking you what is the molar mass of carbon. That means I'm asking you the mass of 1 mole of carbon. I'm asking you the mass of 6.022 into 10 raised power 23 carbon atoms. Right? Similarly, molar mass of water. That means I'm asking you the mass of 1 mole of water. I'm asking you the mass of 6.022 into 10 raised power 23 water molecules. Yeah? Let's try to understand and analyze this in detail. Try to understand carefully, guys, what exactly I'm going to do. For example, I'm writing a statement over here. You need to understand this carefully. For example, I'm writing molar mass of oxygen. Molar mass of oxygen. What is meant by the term molar mass of oxygen? Doesn't it mean that I'm talking about the mass of 1 mole of oxygen? I'm talking about the mass of 1 mole of O. Yes, as per the definition, molar mass of O means the mass of 1 mole of O. Now, my dear students, if I ask you 1 mole of O, 1 mole of O, instead of the term mass of 1 mole of O, can't I write the mass of 6.022 into 10 raised power 23 oxygen atoms? Yes, we can write it. 1 mole oxygen contains 6.022 into 10 raised power 23 oxygen atoms. If I'm writing the mass of 1 mole of O, that means the mass of 6.022 into 10 raised power 23 oxygen atoms. Correct? Now the point is, how can you calculate the mass of 6.022 into 10 raised power 23 oxygen atoms? How can we do that? It's simple, guys. It looks difficult to calculate the mass of 6.022 into 10 raised power 23 oxygen atoms. It looks difficult, but you can simplify it. What you need to do is just calculate the mass of 1 oxygen atom. Just calculate the mass of one oxygen atom. And once you calculate the mass of one oxygen atom, multiply that term by the Avogadro's number. Right? Isn't it simple now? Get the mass of one oxygen atom and multiply that term by the Avogadro's number. You will be getting the mass of 6.022 into 10 raised power 23 oxygen atoms. That means you are getting the mass of 1 mole of oxygen. That means you are technically getting the mass of molar mass of oxygen. Yeah? Now, if I ask you, what is the mass of one oxygen atom? You know, the mass of one oxygen atom is nothing but 16 AMU. Multiplied by what? Multiplied by Avogadro's number. Right? 16 AMU can be broken down as 16 multiplied by 1 AMU. Multiplied by what? Avogadro's number. You know it. Instead of 1 AMU, can't I write 1 by NA grams? Yes, we can do that. Multiplied by its own NA. NA cancel. The value comes out to be 16 grams. So if I ask you, what is the 16 grams? If I ask you, what is the 16 grams? This 16 grams, it is basically what? This is the molar mass of oxygen. This 16 grams, it is the mass of 1 mole of oxygen. This 16 grams, it is the mass of 6.022 into 10 raised power 23 oxygen atoms. Yeah? Right, people? I believe it's clear. This 16 grams, either you can write grams or you can write grams per mole. The choice is yours. 16 grams, it is the mass of 1 mole of oxygen. This is the mass of 6.022 into 10 raised power 23 oxygen atoms. Okay? Now we will think logically. What was the atomic mass of oxygen? Atomic mass of oxygen was 16 AMU. This was the mass of one atom of oxygen. Atomic mass of oxygen. What is the molar mass of oxygen? 16 grams. So don't you see the 16 and 16? It is remaining the same. It is just the units are changing. Nothing else. It is just the units are changing. So, whenever you are supposed to convert atomic mass into molar mass, you are not supposed to change the magnitude. You are just supposed to change the units. Instead of AMU, you are going to write grams, nothing else. Yeah? Right, people? Right? In order to change atomic mass into molar mass, what you are supposed to do? You are not supposed to change the magnitude. Magnitude-wise, it's going to be same. It is just you are going to change the units. Instead of AMU, just write grams. You're sorted. Okay? I believe I'm perfectly clear. Now, guys, one more thing. Over here, I had taken oxygen in atomic form. Okay? Either you'll be calling this 16 grams as the molar mass of O. You'll be calling it as the molar mass of oxygen. Or there is one more terminology which we can use. Since oxygen here is in atomic form, you can call the molar mass as gram atomic mass as well. You can call it as the gram atomic mass of oxygen as well. This is the gram atomic mass of oxygen as well. Okay, perfect. Let me quickly summarize every single thing, people. Let me quickly summarize every single thing so that you can remember it properly. Understand what exactly I'm going to do. With one example, you'll try to understand every single thing. For example, I'm writing N over here, and here I'm writing N2. This is the nitrogen which I've taken over here in which form? In atomic form. And in the second case, I've taken the nitrogen in which form? This is the nitrogen in molecular form. This is the nitrogen in molecular form, right? Now, I'm going to write few terms, and you are going to let me know in the chats what is the meaning of these terms. First term, I'm writing 14 AMU. The second term, I'm just writing 14. The third term is going to be 14 multiplied by 1.66 into 10 raised power minus 24 grams. Now, the fourth term, instead of 14 AMU, I'm just writing 14 grams. These are the four terms which I've mentioned over here. Yeah? Four terms which I mentioned over here. Okay, now when it comes to N2, again I'm mentioning four terms. One is going to be 28U, second is going to be just 28, third is going to be 28 multiplied by 1.66 into 10 raised power minus 24 grams. And the next term, instead of 28U, you are just going to write 28 grams. Let's try to analyze all these things quickly. We will try to understand. What is this 14 AMU? First of all, this is the mass of one nitrogen atom in AMU. right? This is the mass of one nitrogen atom in AMU, which you can directly call as atomic mass of nitrogen. Since you have taken nitrogen in atomic form. What is this 14? You call this as relative atomic mass of nitrogen. What is this term? This is again the mass of one nitrogen atom in grams. This is the mass of one nitrogen atom in grams. And you call this as the actual mass of nitrogen. You call this as the actual mass of nitrogen. Now, if I ask you, what about this particular thing, 14 grams? This 14 grams, this is the mass of 1 mole of nitrogen. This is the mass of 1 mole of nitrogen. This is the mass of 6.022 into 10 raised power 23 nitrogen atoms. Which is what? You'll be either calling it as the molar mass of oxygen, or you will be calling it as the gram atomic mass of nitrogen. Sorry, the gram atomic mass of which element I'm talking about? I'm talking about nitrogen, okay? So this nitrogen here. Right? I believe all these terms are clear over here. Now, look at the other 4 terminologies which I mentioned over here. Look at the other 4 terminologies which I have mentioned, people. What is this 28U? Here, nitrogen is in molecular form. So, this is the mass of 1 molecule of nitrogen in U. This is the mass of 1 molecule of nitrogen in U. So, you call this as directly molecular mass of nitrogen. Okay? This is something which you will be calling as the relative molecular mass of nitrogen. This is the mass of 1 nitrogen molecule in grams, or you can call this as the actual mass of N2. Actual mass of N2. What about this 28 grams? Is this the mass of 1 nitrogen molecule? No. This is the mass of 1 mole of N2. This is the mass of 6.022 into 10 raised power 23 nitrogen molecules. This is the mass of 6.022 into 10 raised power 23 nitrogen molecules, which is what you will be calling as molar mass. Is it molar mass of N? No. This is molar mass of N2. Now, is there any other name for it? Since you have taken nitrogen in molecular form, so instead of the term molar mass, you can call it as the gram. You can call it as the gram molecular mass of nitrogen as well. You can call it as the gram molecular mass of nitrogen as well. If all these terms are clear to you, let me know once in the chats quickly. Everyone means everyone. Class duration will be 3 hours. I believe all these things are absolutely clear to you. Now, people, if I generalize it, I think it is already generalized now. I think it's already generalized, yeah? Right, people? All clear? All clear, all clear, all clear? Quickly in the chats. Perfect. Perfect, guys. Perfect. Now, before showing you the different types of questions which can be formed from the term molar mass, let me give you one simple statement over here. My dear students, take a note of this statement. Whenever you are supposed to calculate molar mass of substance, molar mass of any substance, molar mass of any substance, what does that mean? That means you are supposed to calculate the mass of 1 mole of the substance. That means you are supposed to calculate the mass of 6.022 into 10 raised power 23 particles of the substance. How you will do that? You will first of all calculate the mass of 1 particle of the substance in grams and eventually multiply it with what? Eventually multiply it with Avogadro's number. Right? What do you get? You'll be getting the molar mass of the substance. You'll be getting the molar mass of the substance. Whenever from now onwards, you're supposed to calculate the molar mass of any substance. What do you need? You need the mass of 1 particle of the substance in grams, and eventually multiply that with Avogadro's number. you'll be getting the mass of 6.022 into 10 raised power 23 particles of the substance. So basically, you are technically getting the mass of 1 mole of the substance. And mass of 1 mole of the substance is something which you call as molar mass of the substance, right? And which is expressed either in grams or you can say grams per mole. Okay? For example, one simple and basic question I'm giving you. Let me see if you can solve this or not. Let's say I'm writing the equation. The mass of one atom of element X is equal to 4 into 10 raised power minus 23 grams. The mass of one atom of an element X is nothing but 4 into 10 raised power minus 23 grams. The question is, identify the element. Identify the X. I'm giving you the options as well. Option A, I'm giving you, for example, carbon. B is fluorine. C is magnesium. D is boron. Can you solve this question on your own? Can you solve this question on your own quickly? See guys, the mass of one atom of element X is given, right? We have to identify the element. So how do you identify the element? What am I supposed to do? Think logically. Let me just do one thing. Let me calculate the molar mass of X. Let me calculate the molar mass of the element. What will be the molar mass of the element? How do you calculate the molar mass of the element? It will be equal to mass of one atom of an element multiplied by Avogadro's number. What is the mass of one atom of element? It is 4 into 10 raised power minus 23 grams. This is the mass of one atom of X. I just need to multiply it with Avogadro's number, which is technically 6 into 10 raised power 23. Perfect? Right? So my dear students, this 10 raised power minus 23, this 10 raised power 23 cancel. The value came out to be 24 grams. So what is this 24 grams? This is the molar mass of X. This is the molar mass of X. Perfect? If you got the molar mass of X, what is going to be the atomic mass of X then? What is going to be the atomic mass of X? Molar mass of X is 24 grams. So atomic mass of X will be 24 U or 24 AMU. Correct? Now, which element among the following has got the atomic mass of 24 AMU? It is magnesium. I believe this particular question is clear to every one of you. Yeah? I believe this particular question is clear to every one of you. Right, people? So I was given with the mass of one atom of X. Right? If you know the mass of one particle of any substance in grams, you're just supposed to multiply that with Avogadro's number. What do you get? You'll be getting the molar mass of substance. And since you got the molar mass of substance, now change the units. Instead of grams, write AMU. You got the atomic mass of X. And which element among the following has got the atomic mass of 24 AMU? You know, it is magnesium. I believe this is clear. If this is clear, you can let me know in the chats. If this is clear, let me know in the chats quickly. One simple question. One simple question. Calculate the molar mass of electron. Calculate the molar mass of electron. Calculate the molar mass of electron. So first of all, what does it mean? I am asking you, calculate the molar mass of electron. What does that mean? That means I am asking you to calculate mass of 1 mole of electron. That means I'm asking you to calculate the mass of 6.022 into 10 raised power 23 electrons. And how do you get the mass of 6.022 into 10 raised power 23 electrons? You will first of all calculate the mass of one electron. Mass of one electron in grams. Later on, you will just multiply that with Avogadro's number. Get the mass of one electron. Multiply that with Avogadro's number. You will be getting the mass of 6.022 into 10 raised power 23 electrons. And the mass of 6.022 into 10 raised power 23 electrons is something which I call as the mass of 1 mole of electron. And the mass of 1 mole of electron is what you'll be calling as the molar mass of electron. Yeah? Now, I believe this particular term everybody should be knowing. Mass of 1 electron in grams is 9.1 into 10 raised power minus 28 grams. Now multiply that with Avogadro's number, which is approximately 6.022 into 10 raised power 23. So 6 ones are 6, 6 nines are 54. So 54.6 into 10 raised power minus 28, 23. So 10 raised power minus 5. and the units are going to be in grams. So this is the mass of 1 mole of electron, right? This is the mass of 1 mole of electron. This is the mass of 6.022 into 10 raised power 23 electrons, right? Okay, which is what I'll be calling as the molar mass of electron. I believe I'm perfectly clear with this. Now, one more question which will make the concept little more clear. One more question which will make the concept a little more clear. Look at this question carefully, guys. Look at this question carefully. The question says you have got two elements X and Y. Two elements X and Y. They combine to form two compounds, XY2 and X3Y2. So you have got two elements X and Y which are combining to form two compounds. One is your XY2 and one is your X3Y2. These are the two compounds which we have, XY2, X3Y2. As per the question is concerned, 0.1 mole XY2. As per the question is concerned, 0.1 mole XY2, its mass is how much? 10 grams. Similarly, 0.05 moles of X3Y2. Its mass is how much? 9 grams as per the question. In the question it's mentioned. Okay? In the question it's mentioned. 0.1 mole XY2 has got the mass of 10 grams. 0.05 moles of X3Y2 has got the mass of 9 grams. Now tell me one thing. Tell me one thing. Tell me one thing. If the mass of 0.1 mole XY2 is 10 grams, if you use the unitary method, what will be the mass of 1 mole of XY2? What will be the mass of 1 mole of XY2? If the mass of 0.1 moles of XY2 is 10 grams, therefore the mass of 1 mole of XY2 will be 10 divided by 0.1 grams, which comes out to be 100 grams. Correct? Simple. Similarly, if the mass of 0.05 moles of X3Y2 is 9 grams, therefore the mass of 1 mole of X3Y2 will be how much? 9 divided by 0.05 grams, which comes out to be 180 grams. Correct? Now people, if you think logically, what did we calculate? What did we calculate? If you think logically, what did we calculate? My dear students, this 100 grams, this is the mass of 1 mole of XY2. 100 grams, this is the mass of 1 mole of XY2. And mass of 1 mole of substance. Mass of 1 mole of substance is what we call as molar mass. So basically, this is the molar mass of XY2. Similarly, this is the mass of 1 mole of X3Y2, right? So you'll be calling this as molar mass of X3Y2. Okay, so you got the molar mass of the compounds. You got the molar mass of XY2. You got the molar mass of X3Y2. Now people, if you got the molar masses, can't you convert them into molecular masses? You just have to change the units. So if I ask you what is the molecular mass of XY2, molecular mass of XY2 will be equal to 100 U and molecular mass of X3Y2 will be 180 U. You just have to change the units, right? Okay. Right, people? Molecular mass of XY2 will be 100 U and molecular mass of X3Y2 will be 180 U. Now try to understand. You got to know the molecular mass of XY2. How much? 100 U. Molecular mass of X3Y2. You got to know as how much? Molecular mass of X3Y2 is 180 U. Now, since you got the molecular masses of these compounds, if you think logically again, how do we define the molecular mass? Sum of atomic masses, right? Sum of atomic mass. If you think logically, what is molecular mass? Sum of atomic masses. Let the atomic mass of element X be A. Let the atomic mass of element Y be B, right? Atomic mass of, for example, X is A, Y is B, right? Now, if you think carefully, molecular mass of XY2 is 100. Molecular mass is sum of atomic masses. Atomic mass of X is A. So equation becomes A plus B multiplied by 2. So it is nothing but A plus 2B. So A plus 2B is equal to 100. Similarly, from this particular equation, you'll be getting 3A plus 2B. This will be 3A plus 2B. As per the question, it is 180, right? So you got two equations, so subtract them. When you subtract these two equations, what do you get? 2B cancel. 3A minus A comes out to be 2A. 2A is equal to 180 minus 100 is equal to 80. So from this particular equation, A comes out to be 40. And what was A exactly? A was the atomic mass of X. A was the atomic mass of X. So atomic mass of X is nothing but 40 AMU. So what is the atomic mass of Y? Put the value of A. Put the value of A in any of these equations. Put it here. Put the value of A as 40 here. So 100 minus 40 is 60. 60 by 2 is 30. So B value is 30, right? What is B? B was the atomic mass of Y. Perfect. I hope this is clear to every one of you. If this is clear, let me know once in the chats with some thumbs ups. Quickly. Quickly, people. Yeah, all clear? All clear till here? Quickly, people in the chats, everyone. If every single thing is clear, let me know once in the chats quickly. Everyone means everyone. Perfect, perfect, perfect. So whenever you see this sort of a question, you should be in a position to solve this question, okay? Right? First of all, get the molar masses of the compounds. Once you get the molar masses, you're just supposed to change the units. You'll be getting the molecular masses. Then molecular mass definition you'll write. How exactly? Sum of atomic masses. You'll be getting two equations, two unknowns, solve them and get it done. Okay? And get it done. Perfect. Now comes your one more important topic. That is average atomic mass of an isotopic mixture. Average atomic mass of an isotopic mixture. So first of all, you should be knowing what exactly isotopes are. If I ask you how to define isotopes, how do you guys define the term isotopes? Tell me that. My dear students, isotopes, you know, these are nothing but, these are the atoms of same element. Atoms of same element. Having atoms of same element, having same atomic number, but different mass numbers, right? What are isotopes exactly? Isotopes are the atoms of same element. Sir, what is Avogadro's number exactly? Is it 6.023 into 10 raised per? Avogadro's number is 6.022 into 10 raised per 23, okay? Just remember that. Anyways, it does not make any difference if you use 6.022 or whether you use 6.023, okay? So isotopes, how do you define it exactly? These are the atoms of same element which have got same atomic number but different atomic masses. For example, my dear students, for example, you take the element hydrogen. Let's say you take the element hydrogen, okay? I'm pretty much sure you would be knowing hydrogen. Hydrogen has got three atoms. Hydrogen has got three atoms which have got same atomic number, but their atomic masses are different. This is 1, this is 2, this is 3. So I would say these are the atoms of same element. These are the atoms of same element which have got same atomic number but different atomic masses. So what do I call these atoms as? I call these atoms as the isotopes. So these are the isotopes of hydrogen. These are the isotopes of hydrogen, right? For example, if I talk about chlorine, when it comes to chlorine, what you will observe chlorine has got two atoms which have got same atomic number, but their atomic mass are different, 35, 37. So again, I can say these are the atoms of chlorine which have got same atomic number, but their atomic mass are different. So I'll be calling them as the isotopes of chlorine. So these are nothing but the isotopes of chlorine. So in general, if I need to represent it, how exactly? Let's say you've got the element X. Okay? Let's say you've got the element X. For example, this element, it has got two atoms which have got same atomic number, but their atomic mass are different, M1, M2. So what I'll be calling these atoms as? I'll be calling them exactly as the isotopes of X. I'll be calling them as isotopes of X. Okay, so what are isotopes in general? Isotopes are nothing. Isotopes are the atoms of same element having same atomic number but different atomic masses, right? Now people, try to understand. For example, I'm taking the element X. Let's say I've taken the element X. I'm assuming this element X, it has got, for example, two isotopes. These are the isotopes of the element X which have got same atomic number but their atomic mass are different, M1, M2. Okay? Now, let me tell you one thing and remember it from now on. Whenever the element exists in the form of isotopes, whenever you will see an element having isotopes, for that element, we do not calculate the normal atomic mass. We calculate average atomic mass. So first of all, any element which exists in the form of isotopes, we do not calculate the normal atomic mass for that element. We calculate what? We calculate the average atomic mass of that element. Now the point is, how do we exactly calculate the average atomic mass of an element which exists in isotopes? For that, what do we need? For that, we need the percentage abundance. We need the percentage abundances of these isotopes. What is meant by percentage abundances? You'll get the idea in some time. Right now, you just need to remember. Just remember right now. I'll tell you what is meant by percentage abundance in some time. First of all, remember one thing. Whenever you will see an element which will be existing in the form of isotopes, for that element, we do not calculate the normal atomic mass, we calculate average atomic mass. And in order to calculate the average atomic mass, what do we need? We need the percentage abundances of these isotopes. Now, the percentage abundances of isotopes are represented by A, B respectively. The percentage abundances are represented by A, B respectively. And my dear students, once you get the value of A, B, you will be simply making one formula, which will be M1A plus M2B divided by A plus B. Divided by A plus B. This is one simple formula with the help of which we can calculate the average atomic mass of any element which exists in the form of isotope. Okay, which exists in the form of isotope. Perfect. For example, now we are going to understand it in a better way. For example, let's say I'm talking about chlorine. You can write it in the form of question as well. Okay. Let's say if I talk about chlorine, you know, when I talk about chlorine, chlorine has got two atoms which have got same atomic number, but their atomic mass are different. One is 35, one is 37. Correct? These are the isotopes of chlorine. My dear students, if chlorine has isotopes, then we shall be calculating the average atomic mass of chlorine. And in order to calculate the average atomic mass of chlorine, what do I need? I need the percentage abundance of these isotopes. And experimentally, it has been observed the percentage abundances of these isotopes are 75% and 25% respectively. Now, what does this mean? What does the 75%, 25% mean? Let me tell you that. What is the 75, 25? These are the abundances. These are the percentage abundances. What it means exactly? It means like this. For example, let's say in this room wherein I'm teaching right now, let's say in this room, there are in total some 100 chlorine atoms. Let's say in this room, there are in total 100 chlorine atoms. Now, you know, chlorine exists in the form of either Cl35 or Cl37. It exists in both the forms. So, for example, in this room, there are in total 100 chlorine atoms. Now, you know, out of those 100 chlorine atoms, some of the chlorine atoms will be Cl35 and some chlorine atoms will be Cl35. Now, from this percentage abundance, what kind of information you are getting? You are getting an amazing information. You are getting the information like, among those 100 chlorine atoms, you will find 75 chlorine atoms of which form? Of Cl35. And the remaining 25 chlorine atoms will be Cl37. Right? Okay, so if in total there are 100 chlorine atoms in the room right now, among those 100 chlorine atoms, 75 will be in the form of Cl35 and 25 will be in the form of Cl37, right? So this kind of the information percentage abundance gives us. Okay, now since chlorine has isotopes, whenever the element has isotopes, we calculate its average atomic mass. In order to get the average atomic mass, what do we need? We need the percentage abundances. We got them, right? And these percentage abundances are represented by A and B respectively. This is the value of M1. This is the value of M2, right? So you can quickly use one formula. MAV is equal to M1A plus M2B divided by A plus B. This is the formula which you already know. So MAV is nothing but M1. What is M1? 35. What is A? 75. So it is nothing but 35 multiplied by 75 plus it's going to be 37 multiplied by 25 divided by A plus B comes out to be 100. When you solve this, the value comes out to be 35.5 AMU. So what is this 35.5 AMU? Is it the normal atomic mass of chlorine? No way. This is the average atomic mass of chlorine. This is the average atomic mass of chlorine. So remember, whenever you see an element existing in the form of isotopes, we do not calculate the normal atomic mass for that element. What do we calculate? We calculate the average atomic mass. Okay? Perfect. Now, one thing if you would have realized, 75 plus 25 is coming out to be 100, right? So remember, my dear students, take a note of this statement. The sum of percentage abundance. The sum of percentage abundances of all the isotopes. The sum of percentage abundances of all the isotopes of a particular element. Of a particular element is always equal to what? It's always equal to 100, right? That is A plus B plus C plus dash 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 is always equal to 100. Take a note of this particular statement as well, because this is important, right? This is important. Perfect. This is important. Now, guys, one more important thing. For example, you have got the element X. Imagine that this X has got isotopes. These are the atoms of X which have got same atomic number, but their atomic mass are different. This M1, this M2. So whenever the element exists in the form of isotopes, what do? We calculate average atomic mass for that element, which is represented by MAV. In order to calculate the average atomic mass, what do I need? I need the percentage abundances of these isotopes, represented by A%, B% respectively. Now we'll be using the formula. You know it. What is the formula? M1A plus M2B divided by A plus B. That A plus B value is always 100. That's something which we know. Okay. Now, people, remember one simple thing. Percentage abundance of the isotope. Percentage abundance of the isotope divided by 100. Percentage abundance of the isotope divided by 100 is something which I call as fractional abundance of the isotope. Percentage abundance of an isotope divided by 100 is something which I call as fractional abundance of the isotope. For example, percentage abundance of this isotope is A. If I divide A with 100, I'll be calling this as the fractional abundance of the first isotope. This will be the fractional abundance of this. Similarly, B divided by 100, I'll be calling this as fractional abundance of this isotope, second isotope, right? This A by 100 is the fractional abundance of first isotope. This B by 100 is the fractional abundance of the second isotope. Now, my dear students, try to understand. In the denominator, you have got 100, right? This 100 is the denominator of this part as well as this part, correct? So you can write MAV is equal to M1 A by 100 plus M2 B by 100. Now people, M1 you are writing as such. A by 100. Instead of A by 100, what can you write? A by 100 is what I call as fractional abundance of first isotope plus M2. B by 100 is what I call as fractional abundance of the second isotope. So this is one more result to calculate the average atomic mass of an element. In terms of what? In terms of fractional abundance. In terms of fractional abundance. Okay? Right? Guys, you are watching a live lecture on YouTube. So all those students who are asking me to repeat, there is something called as common sense. You can drag the video a little back. It will be a repetition for you. Okay? Right? In live classes, you do not repeat things. You just drag the video back. It will be automatically the repetition. Okay? Perfect? Yeah? All right. Look here now. So guys, this is one more result with the help of which we can calculate the average atomic mass of an element. Right? And this result is in terms of fractional abundance. The way you wrote a statement over here, the statement was the sum of percentage abundances. The sum of percentage abundances of all the isotopes of a particular element. That's always equal to 100. Remember similar statement. Remember similar statement. The sum of fractional abundances. The sum of fractional abundances of all the isotopes. The sum of fractional abundances of all the isotopes of a particular element. Of a particular element is equal to what? It will be equal to 1. And remember this statement as well, right? This is the sum of percentage, this is the sum of fractions. You know, sum of percentage is always 100 and the sum of fractions is always 1. Correct? Right? Let's try to solve few questions so that you'll understand and analyze these things properly. My dear students, there is one simple question, and this is a asked question, and I'm pretty much sure if you got the concept, you can kill it. See, the question is pretty much simple. You are given with the element boron. As per the question, this boron, how many isotopes it has? It has 2 isotopes. This boron has 2 isotopes. One is B10 and one is B11, right? As per the question, you are given with the percentage abundance of these isotopes, right? So this one is 19% and this one is 81%, right? What are we supposed to calculate? We are supposed to calculate the average atomic mass of boron. How do you calculate the average atomic mass of boron? Average atomic mass of boron is calculated by the formula, that is M1A plus M2B divided by what? Divided by A plus B. Now the point is, what is M1? What is M2? What is A? What is B? See, this is the value of your M1. This is the value of your M2. This is the value of your A. This is the value of your B, right? Now put the values and get the answer. That's it. M1 value, that's 10. A value is 19. M2 value, that is 11. B value is 81. Divided by what? A plus B, that's always 100. When you solve this, the value comes out to be 10.81 AMU. So this is basically the average atomic mass of boron, which I was supposed to calculate. So it's option A, which is going to be the correct answer of this particular question. So people remember, whenever the element exists in the form of isotopes, we do not calculate the normal atomic mass. What do? We calculate the average atomic mass. In order to calculate the average atomic mass, what do we need? We need the percentage abundances of the isotopes, which are represented by A and B respectively. Once you get the value of A and B, you can use the formula M1A plus M2B divided by A plus B. That's always 100, right? Okay. And similarly, percentage abundance divided by 100, that gives you fractional abundance. Perfect. So you can use the other formula as well. M1 multiplied by fractional abundance of 1 plus M2 multiplied by fractional abundance of 2. Okay. Let me give you one more question. For example, a question is like this. Guys, relax. Okay. This will be our last topic for today's session. Let's keep the today's session for 2 hours only, because after so long, I'm taking a live session on YouTube after the NEET 2024 was over, right? I'm also getting used to taking live classes again on YouTube. Okay. So we'll take the first session like 2 hours, 2 hours, 10 minutes like that. Don't worry. Because on every alternate days, we have got the sessions, right? Okay. See guys, look at this question now. For example, you have got the element X. Let's say you have got the element X. I'm assuming this X has got 2 isotopes. One is X35, one is X37. For example, as per the question, the average atomic mass of X is 35.5 AMU. This is the average atomic mass of X. And what am I supposed to calculate? I'm supposed to calculate the percentage abundances of these isotopes. Can you give it a try? I'm supposed to calculate the percentage abundances of these isotopes. You should be in a position to solve this, people. You should be in a position to solve this. You should be in a position to solve this. What am I supposed to calculate? I'm supposed to get the percentage abundance of these isotopes. Now, you know the sum of percentage abundances of all the isotopes. The sum of percentage abundances of all the isotopes of a particular element, that's always 100, right? That's something which you know. Let's assume the percentage abundance of the first isotope as X%. So this will be 100 minus X, 100 minus X, and these percentage abundances you represent with A and B respectively. This is the value of your M1. This is the value of your M2, right? Now, instead of M average, you can write M1A plus M2B divided by A plus B divided by A plus B. As per the question, this value is nothing but 35.5. What is M1? M1 is 35. What is A? A is X. M2 is 37. What is B? B is 100 minus X. A plus B value is always 100. And this value comes out to be nothing but 35.5. Cross multiple, get the value of X. X value after solving comes out to be 75. What was X? X was basically the percentage abundance of X35, which I was supposed to calculate. Therefore, X37, its percentage abundance will be how much? 100 minus 75, which means 25%. Is this particular equation also clear to you? Simple, right? Okay. I believe it's clear till here. All right, let me give you one more question. My dear students, for example, you have got the element magnesium. The element is magnesium, okay? The element is magnesium. For example, this magnesium, it has got 3 isotopes. One is your Mg24, one is your Mg25, and one is your Mg26. These are the 3 isotopes of magnesium. As per the question, the average atomic mass of magnesium is 24.31 AMU. This is the average atomic mass of magnesium, for example. And at the same time, the percentage abundance of this first isotope, that is 79%. I am asking you to calculate the percentage abundances of the remaining 2 isotopes. Can you let me know? Yes, I'll be sharing the PDF also. You can search my channel or the Telegram. It is Wassim Bhat Chemistry Official. Right? Official. Right? I'll be sharing the Telegram. I'll be sharing the PDF of this particular session right after this session in my Telegram. Okay? All right. Now try to solve this question, people. Try to solve this particular question quickly. Quickly. You should be in a position to solve this. See, guys, it's pretty much simple. You know, the sum of percentage abundances, of all the isotopes of a particular element, that's always 100. Okay, right? If the sum of the percentage abundances of all the isotopes of a particular element, if that's always 100, then we are done. As per the question, percentage abundance of the first isotope, that is 79. Now, people, if the percentage abundance of the first isotope is 79, that means what will be the percentage abundance of these 2 isotopes? You know, the sum of the percentage abundance of all these 3, that's 100. Out of 100, the percentage abundance of the first one is 79. That means the percentage abundance of the remaining 2, that will be 21%. So, percentage abundance of this plus percentage abundance of this, that will be 21%, right? Now, out of that 21%, let's assume the abundance of Mg25 as X. This will be 21 minus X. Okay? I believe this particular point is clear to everyone. If this point is clear to everyone, then we are done. How do we represent these percentage abundances? We represent them with A, B, and C respectively. This is the value of M1. This is the value of your M2. This is the value of your M3. So people, I can use the result quickly over here. MAV. Instead of MAV, you can write M1A plus M2B plus M3C divided by, instead of A plus B plus C, it's always 100. And this value is nothing but 24.31. M1 is 24. A value is 79. M2 value is 25. B value is X. M3 is 26. C is 21 minus X divided by 100, and this value as per the question is nothing but 24.31. Now just cross multiplication is needed. You'll be getting the value of X, and X value will come out to be how much? 11%. What was this X? X was the percentage abundance of Mg25. So you got to know the percentage abundance of Mg25 as 11. Therefore, the percentage abundance of Mg26 will be how much? 21 minus X, 21 minus 11, that comes out to be 10%. So these were the two things which I was supposed to calculate as per the question is concerned, right? Yes? Perfect. Now one last question which I'm giving you, but that is going to be your homework question. You are going to solve that question on your own, okay? You are going to solve that question on your own. And part 2 of the mole concept I'll be doing day after tomorrow. If today is Monday, Tuesday, Wednesday at 7 p.m, we'll have part 2 of the mole concept. And I'll be completing this particular chapter in 3 sessions or maximum 4 sessions. So in this week, this chapter will be done. Okay, but you have to be consistent, guys. I want every one of you to be here, right, exactly at 7 p.m. on alternate days. The rest of the information I'll keep on giving you on my Telegram, which is Wassim Bhat Chemistry-official. Okay, perfect. Let me give you one question as the homework, and you guys are going to solve this. And do let me know the answer of this question in the comment section of this particular video. I'm taking the element iron. For example, iron has 3 isotopes: Fe54, Fe56, Fe57. The percentage abundance of the first isotope is 5%. The average atomic mass of iron is nothing but 55.95 AMU. I am supposed to calculate the percentage abundances of the remaining 2 isotopes. Okay? This is going to be your homework question. I would want its answer in the comment section of this particular video. And my dear students, with this, our part 1 of mole concept is done and dusted. Right? The part 2 of this chapter will happen day after tomorrow. That is Monday, Tuesday, Wednesday. Okay. That is Wednesday, 7 p.m. Right? Okay. Similarly, part 3 of this chapter will happen on Friday, 7 p.m. Okay. If part 4 is required, because I'm going to teach every single thing in very detail. Okay. I'm not going to leave anything. If part 4 is required for the chapter, then that is going to happen on Sunday, 7 p.m. So in this particular week, this particular chapter in chemistry will be done. Same goes for physics. In physics also, we will be doing one complete chapter in detail. In bio also, we'll be doing one complete chapter in detail. Perfect. So guys, with this, I'm going to take a leave, right? And do let me know honestly in the comment section how you exactly liked the session. Did you learn something like you never learned before, right, or not? Okay, do let me know honestly that in the comment section of this particular video. So I'm going to take a leave. God bless you all. Take care. I'll see you day after tomorrow at the same time with the mole concept part 2. That is going to be another one amazing session, people, right? You are absolutely going to love that. Okay, perfect. And this particular series is for everyone, whether you are preparing for NEET 2025, NEET 2026, does not matter. Perfect.